ladies and gentlemen. So today we're just going to take a look at factoring perfect square trinomials. Last lesson for this part of the chapter. But a perfect square trinomial is a trinomial with the first and last terms being perfect squares, and the middle is twice the first times the last. And you can see right down here, it's kind of written out for you. But if you remember earlier on, when we were doing our multiplying part of the chapter, we talked about ways that we can do those, okay? So now we're just saying, well, this is going in reverse. If I have the answer to that problem, we can kind of check these, and it saves us a little bit of time. If you don't like this and you want to go back and just factor it like we've practiced with either just factors of the last or our AC factoring, then go right ahead and do that. We're also now going to be working on how do you factor something completely and how do you go through your steps. And I'm going to have a little flow chart for you that you're going to get in class as well. But first thing we always look for is there a GCF I can pull out? Then I look for, is it the difference of perfect squares? I could also check, this is where checking for a perfect square trinomial would come in, but again, that's an optional one. If you don't like it, that's fine. And then you apply, this is for your either factoring by grouping or multiplying and doing those things. So it depends on how many terms there are. But let's get right into this. So first we're just going to double check those, is it a perfect square trinomial, so that we can recognize that. So when I look at this, I have to check the first and the last terms. So I'm looking for, is this a perfect square? Well, I can take the square root of 4. I can take the square root of 9. This, the exponent, is an even exponent. So the first part works. The square root of 4 was 2, and the square root of 9 was 3. And then the square root of y squared is y. So what I'm checking is this middle term 2y times 3 times another 2? So 2 times 3 is 6, times 2 is 12. So yes, this is a perfect square trinomial. So to factor that, right, we do similar to what we did with our difference of two perfect squares. So I'm going to take the square root of this, of 4y squared, and they each get a 2y. I take the square root of 9, which is 3, and then I just check. This time they both get the same symbol. If this is a positive, then they're both adding. If it said a minus, then they would both be subtracting. Okay, so let's try this next one. So again, I have to take the square root of this side, 3x. Square root of this one is 2. So far we've gotten there. Then I have to multiply these just like I did over here. I have to multiply 3x times 2 times another 2. Well, that would give me 12. This says 6. That is not a perfect square trinomial. It doesn't mean that it can't be factored. It just means that now I'd have to do one of my other ways that would come up here. I'd have to do my AC factoring, substitute, and blah, blah, blah. Okay? All right, let's try. I think that's it for there. So now we're going to try somewhere. We're going to go through and we're going to go through and check all of our steps. And remembering that if you can't factor it, you write the word prime. And that just means that right now we can't factor it using integers. All right, so when I look at this one, first thing I'm checking for is there a GCF? So yes, there is. I can pull a 5 out. So I'm going to pull a 5 out, divide everything by 5, so that's going to leave me with x squared minus 16. Now a lot of these, it doesn't mean that you just get to stop there. Now I have to check, can this be factored as well? Well, there's no more GCF, I already did that. But this one is the difference of two perfect squares. I have two things, they're being subtracted, and they're both perfect squares. So to factor that, notice I keep my 5. They each get an x, because that's the square root of x squared. And then the square root of 16 is 4, and then one gets a plus, one gets a minus. Okay, for letter B, I'm checking to see, is there a greatest common factor? And there is not, because it would have to be a 3 or a 9 or a 6, and that doesn't go into 35. So it's not the difference of two perfect squares because it's a trinomial. Because this has a number here and it's not a 1, it has a coefficient other than 1, this is where I have to do my AC. So I'm going to multiply 9 times 35, which is 315. So I need factors of 315 that subtract, so I need factor difference. And just to save some time, I'm going to tell you that it's 21 and 15. All right, remember you can use your graphing calculators to help you come up with factors. Ooh, sorry, I wrote that wrong. There we go. 21 and 15, which subtract to give you 6. Okay, so I'm going to take out negative 6x and I'm going to put that in. So 9x squared, excuse me, minus 21x, because it's a negative, which means your bigger number has to be negative, plus 15x and minus 35. Now I'm going to do my grouping. So, and if you had reversed those, it's okay. You could have written it as plus 15 and minus 21 as long as you can still pull a common factor out. So my common factor here is going to be a 3x. So that leaves me with 3x minus 7. Over here, my common factor is going to be a 5. So 5 times 3x minus 7. As long as these match, then you put those two coefficients together. So 3x plus 5, 3x minus 7. Okay, let's try this next one. So here I'm looking to see, is it a, sorry, is there a greatest common factor? There is not. Then I'm looking, is it the difference of two perfect squares? It is not. Then I'm going to check, which I forgot to do up here, I apologize. I'm going to check to see, is this a perfect square trinomial? Well, that means that I have to take the square root of this, 5c, square root of 1, 1. Okay, now I have to see if I do this times 2, do I get 10? So 5 times 1 times 2 is absolutely 10c. So this is a perfect square trinomial. So I already did the square root of this one. They each get a 5c. They each get a 1. And because that says subtraction, then they're both going to be a minus. Okay, hopefully that makes sense to you. For the letter D, right now, I'm going to look to see, is this a perfect, sorry, first of all, is there a greatest common factor? There is not, because 5 does not go into 12. It is not the difference of two perfect squares, because I have 3 things. It is not a perfect square trinomial, because 12 is not a perfect square. So then this is going to be my AC factoring. So I'm going to multiply 12 times 25, which gives me 300. This tells me they need to subtract, so I'm looking for factor difference. And again, just to save us some time, instead of me going through the whole list, I'm going to tell you that it's 15 and 20, because that will subtract to give me a 5. Okay, so that means I'm taking 5x out and I'm putting in 15 and 20x. So 15, I'm sorry, not paying attention today. So keep the 12x squared plus 15x. I'm sorry, I'm screwing this up so much. The 15 would have to be the negative, 20 has to be the positive, because this is telling me it has to be a positive, so the bigger number has to be positive. So it's minus 15x plus 20x minus 25. And again, if you had put those in reverse order, it's okay as long as there's a common factor you can pull out. So common factor, we're now going to group. Common factor of 12x squared and 15x is 3x. So that leaves me with 4x minus 5. Common factor of 20x and 25 is going to give me, I believe is a 5. 4x minus 5. Oh, thank goodness, those match, which means 3x and 5 can be put together. Okay, so again, we're saving all of this stuff about going through and solving these equations. We're going to save that as a separate little chapter. Right now, we just want to focus on, can you factor these problems? So you'll get a flow chart that kind of goes through and has you do all the guessing. I'll let you add stuff to that. But to factor completely, you go through all those steps and you make sure that there aren't any other extra common factors to pull out in case you missed one. Any questions? Bring them to class. Have a good night.